This week we're going to talk about wide area networks, the telephone system, which obviously goes across the country or across the world, WAN technologies, which get our computer networks across the country or across the world, and MAN technologies, which get us across town, across the city. Before we begin, I want to draw your attention to this little video by Kaufman, How to Learn Anything. It's a TED Talk, and many students find it useful. It has absolutely nothing to do with our topic this week. You're not required to listen to it. There won't be a quiz on it or anything like that. But some people actually really seem to like this video because it helps them stay on track learning a little bit better. So it's there for you to watch if you wish. Let's get going on the telephone network. 1876, Alexander Graham Bell develops the telephone system. Now, he didn't actually invent the whole thing, but he is the one that got Congress to begin to put it into play within our country. Now, the telephone receiver could pick up anywhere from about 3 cycles per second, or 3 hertz, up to about 3.4 kilohertz, which is 3.4 thousand cycles per second, and that's about the range of the human voice. These electrical signals then hit a little drum, just very much like the eardrum, where they would move that little drum back and forth, and then it would create electrical signals, which were carried to the switchboard. Now, this is a private circuit. Notice here, this is a private circuit. In other words, you have an actual physical wire from you to the phone company. The operator plugs that into a little plug, and then you have a physical wire from that switch station to whoever is listening on the other end of the phone. Now, how do you get from one switch station to another? I mean, early on, we would have just a town connected, but we wanted to be able to get across the country. So we had to go from one switch station to another. Well, the phone company used trunk lines to do that. These trunk lines were simply wires, large bundles of wires that went from one switch station to another. There was a problem with that, though. These are still analog signals. These are just simply electrical signals. And over a long distance, that doesn't work so well over a wire because there's resistance in the wire, and these signals kind of peter out, so you can't get very far. Besides that, we still had a problem where you still had to have a dedicated line for each phone call. So let's start talking about some of the solutions. The solution for this first problem, the poor quality or long distance, well, the phone company finally decided to make those lines between switch stations digital, so that your voice from your telephone to the switch station would all be an analog signal, and then from one switch station to another it would be a digital signal, and then it would translate back to an analog signal and go to the other end. Now, these digital signals, what we could do is we could repeat them. So we solved this problem by using, if you apply power midway during that transmission from one switch station to another, you can amplify that signal. It works with digital signals. It doesn't work with analog signals. And so this helps solve that problem of that poor quality over those long distance phone calls. The solution for having dedicated lines came later with something called packet switching. And we're going to study packet switching later. I also want to point out, by the way, that the voice that goes across these digital signals on these trunk lines, the voice is also packetized. That is to say, those digital signals are chunked up into smaller packets. Don't confuse these two terms. Packetization, which is the voice over those trunk lines being chunked up into these smaller pieces, and packet switching, which is something else altogether. They are not necessarily the same thing. We'll talk about packet switching as we go along. So now, the birth of the trunk line. So these lines, these dedicated lines that the phone company put between one station and another, as they were digitized, they began to call them T carriers. Nobody's quite sure what the T stands for. It could be trunk, it could be terrestrial. Some people say it's terrestrial because it's going over on the ground. Some people say it means transmission. Nobody really quite knows, apparently, at least not that I've been able to find any answer that that I can rely on. And each trunk line, each digital trunk line or T carrier could carry 24 phone calls. Now, if you put more of them together, you could get more than that. So we called them T1, T2, T3, and so on. We're going to get into these again a little bit later on. Now, your voice today is still carried by analog signal from your telephone till it gets to the switch station, which is called, by the way, the central office. And then from one central office to the next, of course, across those trunk lines, and then it becomes analog again and goes out to the guy on the other end or girl on the other end. Now, this all worked well until 1984, when the Bell Phone Company was broken up, anti-monopoly suits and all of that. So the U.S. government broke it up, and this, by the way, was called the Modified Final Judgment of 1984. Kind of a silly name for something specific like this. Just the Modified Final Judgment doesn't sound like it has anything to do with the phone company, but that's what it was called. Now, at this point, there was a problem. That you now had 7 companies, and so how do you tie one company to another company so that you can get from one place to another place that is under the auspices of a different company? Because now each of these 7 companies had their own 7 telephone networks. Well, each company had something called a point of presence that actually was a set of trunk lines that would go to the POP, or the point of presence, for the other companies. So you had 7 of them. So if I was company number 1, I would have to have a point of presence for the other 6 companies out there. And that way I could get to their point of presence and then back into their system. Now, I'm going to come back to these trunk lines for a minute. These trunk lines were pretty cool. They were digital. And some large companies caught on to that and said, wait a minute, could we get some digital lines? I mean, after all, you can carry 24 voice channels across one of these digital T1 lines. Well, we could carry 24 digital channels for our computer systems across lines. And so they began asking the telephone company for some T lines to go between Office A and Office B. This gets you across town, right? Basically, you really probably wouldn't go across the entire country this way, but these T lines, the phone company began to install these T lines for other businesses. Now, another point of terminology here, by the way. The point between the phone company, in other words, that CO office that we saw earlier, and your phone set, where it's still in analog, that's called the last mile. So that's just a piece of terminology. Now, eventually, DSL came in. DSL, or actually more accurately called ADSL, but we'll just call it DSL at the beginning, and then I'll explain what ADSL means. DSL is Digital Subscriber Line, and it offered homes and businesses, in other words, that digitized, remember I said it was analog, between the phone company, the CO, the central office, and your phone. Well, they began to digitize that last mile, and so what they did is they had something called the DSLAM. That should be SLAM. I typed that. It should be like this: DSLAM or DSLAM. In other words, that adapter module. Or access multiplier, excuse me, is what that means. DSL access multiplier. What they did is they put these DSL or DSLAM units at the phone company and then digitized between the phone company and your home or your business. This gave a fully digital line to organizations or to individuals who wanted to buy these DSL lines, and now they could put their computers on these things. Very clever. Now, ADSL or asymmetric DSL refers to that the fact that what they did is they took some of those those channels. You would get half the channels for uploading and half the channels for downloading. And they would say, well, you know, downloading is where all the data is, right? You spend more time downloading than you do uploading. I request a web page, it's only one tiny request, but the web page is big. So now this is before the web, but that just gives an example of what I mean by download speed being or requirements being more than upload requirements. And so they stole some of the upload channels and gave them to the download channels and called it asymmetric DSL, because download speeds are faster than upload speeds with asymmetric DSL. Now these are still dedicated links, and there are some companies, by the way, put up their own private DSL lines, but at the telephone companies there were still dedicated links, dedicated lines. They still had to be switched through the telephone system just like any other. At this point, they were no longer just operators doing it. It was a little bit more automated than that. Well, that's pretty much it for the phone company, and we're going to go on and take a look at television in the next video.